Hello everyone, welcome back to the course on cryptography and network security. So in today's session, we will be on discussing about DES algorithm. In the previous session, we discussed about simplified DES algorithm. So with respect to our 8-bit of plain text, we're converting into an 8-bit ciphertext by making use of 10-bit key value. In today's session, we will discuss on the introduction to DES algorithm. So what are the various features of DES algorithm, advantages, limitations, and the various applications where we can able to apply the DES algorithm. And also we'll be studying on DES architecture and the single round of Feistel structure explanation. The learning objective of this session, after this session, the students will be able to understand the DES algorithm basics, explain DES architecture clearly, and able to identify the advantages and the limitations. So they will be able to describe the real world applications where we are applying the DES, and also at the end they can able to analyze the single round of operation. So now we go to the introduction to DES. DES is nothing but Data Encryption Standard. It is a symmetric key block cipher technique, so developed by IBM. So and it is adopted in the year 1977. So DES algorithm encrypts the data in terms of blocks of size 64 bits, and also it is going to be using 56-bit of effective key in order to encrypt the one block of data. So it is going to be work on the basis of Feistel network structure. So we have already discussed in the previous session in the simplified DES algorithm. So how the Feistel structure is going to be incorporated in DES algorithm. The key features of DES algorithm, it mainly consists of 64 bits of block. So whatever may be the message size, so the entire message will be get divided into the equal size of block of 64 bits. And the key size, initially we are going to be make use of 64 bits, but when it comes to performing the encryption of the block of data, so it will be get converted into 48 bits. So and it is going to be follows a standard of 16 rounds of operation, and it is going to be make use of the concept substitution and permutation, or also we can call it as confusion and diffusion. The same algorithm we are going to be used for both side encryption as well as the decryption. When it comes to the advantages and limitations of the DES algorithm, so first of all, advantages: it is simple and well structured design. It is an efficient algorithm in order to implement in a hardware. It provides the strong confusion and diffusion properties, and widely studied and analyzed algorithm is of DES, and it is a foundation for modern cryptographic systems. So when it comes to the limitations and all, the very first limitation is the size of the key what we're using to encrypt our block of data. So because of the small key size, it is vulnerable to the brute force attack. Advances in computing make it insecure today, susceptible to cryptanalysis attack, and also not suitable for the modern high security applications due to the less bits of key size. So this algorithm has been replaced by advanced encryption standard because of the various limitations. So the AES algorithm is going to be cover the maximum limitations of DES algorithm. So when it comes to the applications of DES algorithm, so early banking systems, so in order to encrypt the ATM pin, they're going to be using a DES algorithm, and the secure communication in legacy systems, so used in the payment systems in the earlier standards. And also this algorithm will become a basis for triple DES. So 3 times the DES algorithm security we are going to be using in various applications. And also we are going to be using this application, that is DES algorithm, for the educational purpose to understand how the cryptography is going to be working in terms of encrypting and decrypting our plain text. So now we try to understand the DES architecture, the overview. So the right side what we are going to be seeing the entire architecture. The right side of this diagram we have a key, So for every round, we'll be going to make use of unique key from the original 64-bit key, and the one block of data of size 64-bit we are going to be using to perform encryption. So very first case, at the very first step, 64-bit plain text is going to be performing initial permutation, that is nothing but rearranging the bits of the given plain text. So once we are done with the step 1, that is initial permutation, that bits will be given as an input to the very first round. So and at the right side, the 64-bit, so we are going to be permuting the choice number 1. So at very first stage, we'll be going permuting. That means every 8 bit of the 64-bit key we are going to be eliminating. So from that permutation choice, we are going to be get 56 bit. So from that 56 bits, we are going to be performing the left circular shift operation by 1 bit. Then we'll be going performing the permutation once again. So from this permutations, we are going to be eliminating another 8 bits. So finally, we are going to be make use of 48 bit. So at the round 1, we all know that the Feistel structure is going to be work in terms of dividing into an equal half. The left side will be 32 bit, the right side will be 32 bit. So then performing the 16 Feistel rounds, the swap the halves and apply the final permutation. So we will be able to get our 64-bit ciphertext. So at every round, we'll be going to make use of 48-bit unique key, so which we are going to be deriving from the main 64-bit key. So at the end of the round 16, whatever the output which is going to be produced by the round 16, we just go on performing. So 32-bit swap, the left and the right side bits we are going to be performing the swapping, and then so whatever we have done at the step 1, the initial permutation, we are going to be performing the inverse initial permutation, so that we will be able to get our 64-bit ciphertext. So this is how the DES algorithm is going to be worked to produce one block of data size 64-bit. So likewise, how many bits will be there when we communicating with the other side? The message, the entire message will be get divided into the equal size, and we will be able to generate the ciphertext of the equivalent plain text. So here, just in order to understand how the single round, the structure of the DES algorithm. So in the previous diagram, we have seen the 16 rounds are there. Here we just try to understand how that each round will be gone performing it. The core focus of this particular round. So once we have done with the initial permutation, that 64-bit is giving as an input to the round 1. So in the round 1, very first step is dividing that into an equal half. Then we'll be gone performing the round here. See here. So I'll be gone dividing the left half and as well as the right half. So the right half 32-bit will be gone performing the expansion permutation. So expansion permutation means that nothing but we just go on expanding into an 42-bit size, because the key which we are going to be using here, the 42-bit, and the input right side we have to be convert that into an 48-bit. So now we will be gone performing the XOR operation. So the output which you are going to be get as 48-bit. So now we will be gone performing certain substitutions. So by making use of that values and all, so 8 substitution boxes we are going to be make use. So in every S box, it will be gone contains 6 bits will be there. So those 6 bits we are going to be eliminating or converting into the 4 bits. So we are going to be make use of the standard substitution box. So by referring with respect to that, we'll be gone replacing the, so first and the last one we are going to be considered to refer as the row, and the middle 4 bits we are going to be used to represent as the column 1. So in that cases we will be gone replacing. So total 8 S boxes. So all we are going to be converting into an 32-bit size. Then so we are going to be performing the permutation, that is transposition. Then afterwards whatever the 32-bit will be there, so that I'm going to be performing with the left half of the value XORing the operation. So finally I'll be able to get the right half, and the right half will be coming into the left half. So these 64-bit will be working as an input to the round 2. So the same thing which we are going to be exploring over in the left. So the very first step is dividing into half, performing the round key operation. So before that, we need to be expand the right side half 32-bit to 48 bits. Then we have to be gone performing XOR operation. So the resultant will be 48-bit. So then afterwards, we need to be going divide into 8 groups of 6 bits. So each group is going to be having a 4 bits. The output becomes 32-bit. That is nothing but 6-bit is going to be get converted into 4-bit size. So then we'll be gone performing the diffusion called the permutations and all, rearranging the bits for the diffusion. Then at the final step of the right side is XORing with the left hand side. So it is going to be generate a new right half. Then we just go on performing the swapping that. So now, so whatever we have discussed about the DES algorithm and all, so DES is a milestone in the case of cryptography techniques. So it has been introduced the Feistel structures concepts. So though it is outdated, still important for academic learning and understanding the modern algorithm. So this DES algorithm will become a base in order to understand the more sophisticated modern cryptographic techniques. So with this, we are ending the session. So next, we try to discuss about the next algorithm called AES algorithm. Thank you.